Well, you can say this question of probability is not that tough. This is not at all tough because it involves simple basic probabilities involved with quadratics. You can read the question comfortably even later on by coming back to this portion of the video, and we can start solving this question from its scratch value. Say we have two coins, unbiased coins, such that the probabilities of getting head in a single toss are 2 by 3 and 1 by 3. That means they are talking about probability of the first coin getting a head is a 2 by 3. And probability of the second coin getting a head is equal to 1 by 3 as per this much of information. Now suppose alpha is the number of heads that appear when C1 is tossed twice. A coin is tossed twice. How many heads can you get? 0, 1 or 2. That's all. That means values of alpha can be 0, 1 or 2. That's all. Now next we can get the values of beta as well similarly. And values of beta would be like this. Beta again is the number of heads that appear on C2 when it is tossed twice. So beta can generate 0 heads, the second coin can generate 0, 1 or 2 heads respectively. Now using these you can calculate the probabilities respectively for P1. I mean to say P1 of 0, P1 of 1, P1 of 2 and like this. So let's proceed for that. Let's say probability of 1 for alpha equal to 0 would be equal to how much? No heads from the first coin. That means 1 by 3 and it is tossed how many times? It is tossed twice. So therefore in the first tossing you get 1 by 3, in the second tossing another 1 by 3. Done. Now probability of the first coin for alpha equal to 1. Probability of the first coin for alpha equal to 1 would be equal to means there is one head and one tail. There are two tosses going on. Now that means the head can come first or the tail can come first. That means it can be a 2 by 3 into a 1 by 3, 2 by 3 into a 1 by 3, head and a tail, or a tail and a head, and hence it can be taken two times. Now the first coin with alpha equal to 2 means you are getting two heads. If you are getting two heads, it's a 2 by 3 first time and a 2 by 3 probability the second time. That's all. These are the probabilities of the first coin under respective values of alpha. Now let's go to the second coin in this question. Again beta equal to 0. That means second coin having a probability for beta equal to 0 means 0 heads. Both are tails. That means 2 by 3 for a tail, 2 by 3 for a tail. That's all. And that can happen only one way. Second coin with getting only one head means one head means you get a head here 1 by 3 or you get a tail next, or it can be the vice versa. That means it can be a head tail or it can be a tail head combination. Then in the third case, the probability of the second coin for beta equal to 2 means both are heads with a probability of 1 by 3 each. This is 1 by 3 each. This is how we configure the probability distribution of the two coins under different cases of heads coming up. 0 heads, 1 head, 2 head, 0 head, 1 head, 2 head. Now what is asked in the question? Suppose alpha is the number of heads that appear on C1 and beta is the number of heads that appear on C2 on tossing twice independently. Find probability that the roots are real and equal for this quadratic. Roots are real and equal means the discriminant of that quadratic should be 0. And that means alpha square minus 4 times beta value should be equal to 0 for this quadratic. And when can this happen? Under these set of alpha and beta values. Either when alpha is equal to 2 and beta is equal to 1. This is one possibility. 4 minus 1 can lead to 0. This is a possible solution. Or else both are 0. Let's say alpha 0 and beta 0. This is also an acceptable solution of this particular requirement. And that means if this is, let's say, event E1, then probability of event E1, let's say this is event E1 and let's say this is event E2, this is event E2, then our requirement is probability of event E1 and union event E2, and that is probability of E1 plus probability of E2, and there is no intersection between these two events, so E1 intersection E2 is not going to be counted. Now probability of E1, that alpha is 2. When alpha is 2, I have a 2 by 3 into 2 by 3 and beta equal to 1. 2 by 3 into 2 by 3 and beta equal to 1. When beta is equal to 1, where are you when beta is equal to 1? You are at 2 into 2 by 9. 2 into 2 by 9. That is for beta equal to 1 from here. That means alpha equal to 2 relates to beta equal to 1 in this calculation. And in the second event, both are 0. That means this one relates to this one. So therefore, we have a 1 by 9 from here and a 4 by 9 from here. And if I go for the final counting, we are almost at the end of our calculation. And now you see what we have. 9 cross 9 makes an 81. And we have 4, 4, 16 plus we have a 4 by 81 and that makes it equal to 16. 4 cross 4, 16. 16 by 81 plus 4 by 81, that makes it 20 by 81. You see this, 20 by 81. So 20 by 81 is going to be your right answer, and the answer of this question should be equal to 20 by 81. This is how we solve a probability question with the distribution involved and with the conditions involved and different concepts. This is an advanced 2020 question. This is an advanced 2020 question. This is how we have a question on probability on advanced. Thank you for your patience. See you in the next question.